Hi students, in this video we're going to cover polynomial inequalities. Our objectives are to graphically verify the solutions to polynomial inequalities, to solve a polynomial inequality by factoring, and to express those solutions in interval notation. So a polynomial inequality is expressed in the form f of x is greater than 0 or f of x is greater than or equal to 0. We can also have less than or equal to, but you just need 0 on one side of the inequality. The solution to a polynomial inequality is a set of values that make the inequality true, and that's going to be in interval notation where we use parentheses or brackets to express that. And on the next slide, we're going to talk about the zeros for an inequality. So the zero for a function, remember, is where the graph crosses or touches the horizontal axis. And that's going to mean that before and after the zero, the function is either positive or negative. So we see at our 0, negative 2, 0, that right like before you get to x equals negative 2, the graph is positive. And from negative 2 until we get to positive 5, the graph is negative because it's below the x-axis. So positive is going to mean above the x-axis. Negative is going to mean below the x-axis. And so these zeros act as boundary points for our function. And so when we make our sign chart to get our intervals for our solutions, the zeros are going to be those boundary points. The steps for solving a polynomial inequality graphically are going to be graph the function. I highly recommend using Desmos. Then we want to identify the zeros of the function, and we want to shade the range of values that satisfy the inequality. And of course, we want to write that in interval notation. I left that out. So for write solution in interval notation. And our first example is x cubed minus 4x is greater than or equal to 0. So our zeros are negative 2, 0, and positive 2. We want where the graph is greater than or equal to 0. This means above the x-axis. So above the x-axis is just going to be this portion that I'm tracing now. So from negative 2 to 0 is part of our solution. So negative 2 to 0 union. Then the other portion is from 2 to infinity because that part is also above the x-axis. So from 2 to infinity. And that's it. The next example we have is x to the 4th minus 5x squared plus 5 is less than 1. So first, you have to make sure 0 is on one side. So that's the same as x to the 4th minus 5x squared plus 4 is less than 0. So identify our zeros. That's going to be negative 2, negative 1, positive 1, and 2. And below the x-axis is going to mean negative. So we're less than 0. So from negative 2 to negative 1 and from 1 to 2. So our solution is from it's from negative 2 to negative 1 union 1 to 2. And that's it for this one. So analytically solving polynomial inequalities, we have to make sure one side of the inequality is 0. We need to factor the inequality to find the zeros. We make a number line with our boundary points. We identify an x value between each one of those boundaries. And then we record a sign, positive or negative, in that boundary. And the boundary that has the correct sign, positive for greater than, negative for less than, that's going to be the solution for our inequality. So we're going to use the same example that we already worked. The x cubed minus 4x is greater than 0. So we know our boundary points are -2, 0, and 2. So the inequality is already 0 on one side. We have to factor to find our boundary values. So x cubed minus 4x, the first thing you always do when you factor is take out a greatest common factor. That's going to be x. So we have x times x squared minus 4. And that factors to be x times x plus 2 times x minus 2. And so our solutions are 0, -2, and 2. That's how we get our boundary values. So then step 3, we need to make a number line and find our solutions. So we have this number line. It's from -2. All right, so I should mention that there's a negative. You go to negative infinity on the left and positive infinity on the right. So we have to find a value that's in this boundary, another value that's in this boundary, a value that's in this boundary, and a value that's in that boundary. So our first boundary is from negative infinity to -2. So you can choose any value that's less than -2. I would choose x equals -3. If you substitute -3 into that function, you get -15. You only care about the sign, so that's going to be just a negative. Then then you can choose a value between -2 and 0, like x equals -1, and that gets you a +3, so that's going to be positive. A value between 0 and 2, something like x equals 1, if you substitute 1 into the function, you get -3, so that's going to be a negative. And then if you choose a value between 2 and infinity, you could get x equals 3, for instance. If you substitute in 3, you get 15, which is going to be positive. So you can see the graph actually matches this. When x is -1, when x is -1, the graph is positive. When x is -3, like over here, is somewhere down here, really negative. When x is +1, the graph is here. So you can see the sign chart matches, and you don't actually need the graph of the function. You can just use the function values to get that. So the green intervals are where we want our solution to be because we say greater than 0. So our solution is going to be -2 to 0 union 2 to infinity, because those are the intervals where we are positive. So that's how we make our sign chart with our boundary values. So now we're going to, and you see the solution pops up. I already wrote that. So it just says -2 to 0 and 2 to infinity. So now we want to solve this example where we have x times x plus 1 times 2x minus 3 is less than 0. So the first thing is we have to make sure 0 is on one side. Done. 2, we need to factor. Also done. 3, we need to, well, part of 2 is we need to find our boundary values. So we get x equals 0, x equals -1, and x equals +3/2. So those are our boundary points. So now we make a number line with our boundary points. So we're going to put from least to greatest, so -1, 0, and 3/2. So now when you have this factor version, all you care about is the sign of the number and not necessarily the actual number. So it's easier to just multiply the signs together and see what results. So a number between -infinity and -1, I would choose x equals -2. So if x is -2, you would have a negative value multiplied by another negative value multiplied by another negative value. So 3 negatives are going to make a negative. If I choose a value between -1 and 0, like x equals, -1/2, then the first thing is still going to be negative. Negative 1/2 plus 1 is going to be a positive value. And what, negative 1 minus 3 is going to be negative. So when you multiply a negative, a positive, and a negative, you get a positive value. So two negatives times a positive make a positive. If I choose some value between 0 and 3/2 or 1.5, like x equals 1, then when x is 1, the x is going to be positive, x plus 1 is going to be positive, and 2 times 1 minus 3 is still going to be negative, so we get a negative value. And so then if I choose the value between 3/2 and infinity, then I can choose x equals 2, for instance. So if x is 2, then 2 is positive, 2 plus 1 is positive, 2 times 2 minus 3 is also positive. So 3 positives are going to give me a positive value. So we want where the inequality is less than 0. So that's going to be the intervals that have negatives. So that would give us negative infinity to negative 1 union 0 to 3/2. And that's it. The next example we want to solve is x squared times x plus 5 times x minus 7 is greater than or equal to 0. Again, this is already factored, so we need to set x squared equal to 0. That's going to mean x equals plus and minus 0. We want to set x plus 5 equal to 0, which means x equals negative 5. And we want to set x minus 7 equal to 0, which means x equals 7. So our boundary values are negative 5, 0, and 7. So we put negative 5, 0, and 7 on our number line. And then, again, we're going to just choose numbers in each of these boundaries. So we're going to have between negative infinity and negative 5, let's use x equals negative 6. So if we use x equals negative 6, then negative 6 squared is going to be positive. Negative 6 plus 5 is going to be negative. And negative 6 minus 7 is also going to be negative. So a positive times a negative is going to give you a positive value. On the interval negative 5 to 0, say I choose x equals negative 1, then negative 1 squared is going to be positive, negative 1 plus 5 is going to be positive, and negative 1 minus 7 is going to be negative. So two positives times a negative is going to give you a negative value. If I choose x equals 1 for the interval 0 to 7, then 1 squared is going to be positive, 1 plus 5 is going to be positive, and 1 minus 7 is going to be negative. So we get the same thing that we got on the previous interval, which is also going to be negative. And last is from 7 to infinity. If I choose x equals 8, 8 squared is positive, 8 plus 5 is positive, and 8 minus 7 also positive. So 3 positives multiplied give you a positive value. So where this is greater than or equal to 0 is going to be negative infinity to negative 5, bracket because of the equal bar for the inequality, union 7 to infinity. That's it. And so our last example is going to be a good review for factoring, and it's going to be one where we have to move the values to the other side. So we have to solve 10x squared plus 13x minus 1 is greater than or equal to 2. So you subtract 2 from both sides and you get 10x squared plus 13x minus 3 is greater than or equal to 0. So you actually need to factor this one. So remember, for factoring a trinomial, you want to multiply the 10x squared and the negative 3. That's going to give us a negative 30x squared. And we want factors of negative 30x squared that can give us 13. So that's going to be positive 15x and negative 2x. So we rewrite this to be 10x squared plus 15x minus 2x minus 3 is greater than or equal to 0. So next we factor by grouping. So we can take out a 5x from the first group. So 5x times 2x plus 3. And from the second group, we can factor out only a -1. So we get -1 times 2x plus 3 is greater than or equal to 0. So then our final step is to pull out the common factor of 2x plus 3. So we get 5x minus 1 times 2x plus 3 is greater than or equal to 0. So our two boundary values are x equals 1/5 and x equals -3 divided by 2. So the number line that we make is going to have -3/2 and +1/5. So now you just have to choose a value on each one of these each one of the boundaries and get your solution. So between -infinity and -3/2, I would use x equals -2. And if you do that, so we're substituting this into 5x minus 1 and 2x plus 3. So 5 times -2 minus 1, that's going to be negative. And 2 times -2 plus 3 is also going to be negative. Multiplying two negatives results in a positive value. If we choose a value between -3/2 and 1/5, I would choose x equals 0. If you choose x equals 0, 5 times 0 minus 1 is negative. 2 times 0 plus 3 is positive. A negative times a positive yields a negative value. And then between 1/5 and infinity, I would choose x equals 1. If I choose x to be 1, 5 times 1 minus 1 is positive, and 2 times 1 plus 3 is also positive. The result of multiplying two positives is a positive. So we want where this inequality, well, it could be this one too, that inequality is greater than or equal to 0. Don't use this sign because it could turn out that you have to divide by a negative or something. Use the one where you have 0. So where that is greater than or equal to 0 is going to be -infinity to -3/2 bracket union 1/5 to infinity. And that's it. So that is solving polynomial inequalities. We'll do some practice in class. See y'all later.